Good morning, students. So, in the previous class, we were discussing about some basic construction material that are used in the construction of buildings, bridges, and other construction sites. So, we were discussing about cement, fine aggregate or sand, coarse aggregate, bricks, tiles, timber or wood, paint, steel, right? So out of those basic construction material, the first building material that we have taken into account is cement. The quality of cement must not be compromised, otherwise that would be a great threat to the integrity of the building. So that is why several tests are conducted to check the quality of cement. Out of those tests, some fundamental or basic tests are fineness test of cement. Please take down the notes while I am writing here. Consistency test. Initial setting time test. Final setting time test. Firmness test of cement. Compressive strength test. And tensile strength test. All these 7 experiments are conducted in the laboratory using certain equipments. Indian Standard Code 4031 gives recommendation about the procedure and the equipments to be used while conducting the experiment. Apart from these experiments which are conducted in the laboratory, there are certain tests that we can carry out in the field without using any equipment to check the quality of the cement. For example, if you are provided with a bag full of cement and you are not given any equipment, so at that time you can check its quality by looking at the color of the cement, by rubbing the cement in your fingers. You can also throw a little amount of cement into a bucket of water and see the settlement period. From these little experiments, you can check the physical properties of cement and you can conclude whether the cement is of good quality or of bad quality. So first of all, you have to check whether the color is greenish gray or not. A good quality cement must have greenish gray color. If the color has changed, that means the cement has absorbed moisture and its quality has deteriorated. If you insert hand into a bag of cement, then you must feel cool. If you are inserting your hand into a bag filled with cement, then you must feel cool. If you feel hot, then that quality of cement has been deteriorated. Then if you rub the cement between fingers, it must feel smooth. No lumps should be present. In the bag of cement, there must not be any lumps. And if you throw or put little amount of cement into a bucket of water, it must settle down slowly. So these are few physical properties of cement that can be checked by us without using any equipments in the field. We can check its color. It should be greenish gray in color. If we rub the cement between fingers, it must feel smooth. If we insert our hand into a bag of cement, it must feel cool. No lumps should be present. And if we are throwing a little amount of cement into a bucket of water, then it must settle down very slowly. So in laboratory, we are going to conduct all these experiments step by step. So you have to recall the tests by its sequence. It's always fineness test, consistency test, initial setting time test, final setting time test, and soundness test. We cannot conduct initial setting time test without conducting consistency test. So you have to recall all the names of the tests by its sequence. Alright, so shall I clear it? So the first test cement. Indian Standard Code 4031 gives recommendation regarding the procedure of conducting this experiment. There are three ways by which we can conduct this test. First one is the seed paste. Second one is air permeability. Test, or this is also known as plains air permeability. Test. And the third method of knowing the fineness of cement is Wagner's turbidimeter test, in which sedimentation technique is used to find out the fineness of cement. In our internship program, we are going to conduct seed test. So I will describe the procedures of seed test with dry seed test of cement. So I will describe the procedure minutely. Done, completed writing? Shall I clear? Go. Completed? Go. Picture on the screen. This picture is representing the lumps in cement. The lumps are formed in cement as the cement absorbs moisture from atmosphere into it. Okay. So a good quality cement must not contain any lumps. It should be free of lumps. Tasting. The apparatus that we require are 90 micron C. Next one is a weighing balance with an accuracy of 0.1 gram and 100 gram of cement. So what will we do in this experiment? First, we on the weighing machine. Then we put a porcelain dish onto it and we set it to 0. Okay, then we would add some amount of cement into that porcelain dish and we will measure it to 100 grams. Once we have measured 100 grams of cement, then we will transfer the cement into the sieve setup. The sieve setup consists of a 90 micron sieve above a pan. Okay, so we will then transfer the cement onto the 90 micron sieve, cover it with a lid. Below that there will be a pan. Alright, then we have to either take that setup to a sieve seeking machine, or we have to stake that setup in our hands. If we are staking the setup in our hands, then we have to make sure that we are sieving it for at least 15 minutes. In that 15 minutes, we have to move that setup in clockwise direction, in anti-clockwise direction, in forward as well as in backward directions. Once it is shaked well, we have to also check into the 90 micron sieve whether there are some lumps present or not. If we see any lumps, then we will break it with our hands and we will again continue the sieving. Alright, after 15 minutes, we would look into the 90 micron sieve if there are any residue or there are any cement retained on that 90 micron sieve. Most of the cement have been passed through the 90 micron sieve into the pan, but we have to look for the amount of cement that has retained on the 90 micron sieve. Okay, so we will collect that residual amount of cement into the porcelain dish that has been set up to the 0 mark on the weighing balance. Then we will weigh the residual amount of cement present on the 90 micron sieve. And after that we will find the percentage of fineness. How are we going to find the percentage of fineness? It is the weight of residual cement on 90 micron sieve to the original weight of cement into 100. Let us assume the residual amount of cement is 5 grams. The original weight of cement was 100 grams, right? 5 divided by 100 into 100. What is the percentage of fineness here in this case? 5%. So there are certain standard limits of percentage of fineness depending upon the variety of cement used in the experiment. For ordinary Portland cement or OPC, the value of percentage fineness of cement should be less than 10%. We will conduct the experiment and you will be provided with OPC. Okay, so you will be provided with OPC. So now you know for OPC the percentage of fineness should be less than 10%. If you are getting any value higher than 10%, then you know that the integrity of the cement has been compromised. You cannot use that cement in the construction. For Portland, pozzolana cement or PPC, and rapid hardening cement, the value of percentage of fineness of cement should be less than 5%. These values are not only important for your laboratory work, these values are also important for competitive exams. So do recall these values. For OPC, the percentage of fineness should be less than 10%. For PPC and rapid hardening cement, it should be less than 5%. Then, shall I clear the board now? Now, you have known what is the test conducted to find out the fineness of cement. You know the procedure of sieve test as well. You must know what is fineness. The degree of fineness means the measurement of mean size of cement. In order to measure the mean size of the grains of cement, we have to conduct the fineness test. Usually, the mean size of cement varies between 75 micron to 90 micron. Okay. So, the degree of fineness represents the measurement of the mean size of cement. What are the effects of fineness test? First we will check its effect on the surface area. I have already discussed this effect with you with an example of a cube, right? So if we are taking a cube of size, let us say 2 centimeter, then its volume will be side cube. So 2 to the power 3 equals to 8 centimeter cube. What is its surface area? On its one side, on its one face, the surface area would be 2 into 2 equals to 4 square centimeter. Its total surface area will be, how many faces does a cube have? vertically and horizontally through its midpoints on the edges. Then we will get small cubes of side 1 centimeter, and we will have 8 number of such cubes, right? I demonstrated you that day. So now its volume will be 1 cubic centimeter, but there are 8 number of cubes, so total volume will be 8 into 1 equals to 8 cubic centimeter. Its surface area is 1 square centimeter. Total surface area is 6 into 1 equals to 6 square centimeter. How many number of cubes are there? 8 numbers of cubes. So for 8 number of cubes, the total surface area will be 6 into 8 equals to 48 square centimeter. So we can clearly observe that due to fineness, the surface area is increasing. If we consider this cube as a cement particle, so we can see that if we are grinding this cube into smaller particles, then there is no change in its volume, but the surface area is increasing. It's twice, it's 2 times the first case, right? So because of fineness, the surface area is increasing. You can conclude that. So as the surface area is increasing, the contact with water will also increase, right? More surface area, so there will be more area for water to have its contact with cement, right? So the contact with water will increase. I'm hearing it. So due to fineness, the surface area increases. As surface area increases, contact with water increases. As contact with water increases, the cement reacts with water, resulting in a exothermic reaction, and in this process heat is generated. That heat is known as heat of hydration. So as the contact with water increases, the reaction between cement and water that occurs in an accelerated way, so the heat of hydration will be high. As the reaction between cement and sand is as the reaction between cement and water is higher due to fineness effect, so the cement will attain early strength rapidly. Bleeding will be minimum. What is bleeding? You will ask. Look. In order to understand what is bleeding, we need to understand what is concrete. What is concrete? It is heterogeneous mixture of cement, fine aggregate, or sand, coarse aggregate, and water. So concrete is a heterogeneous mixture. It is a heterogeneous mixture of cement, fine aggregate or sand, coarse aggregate and water. What happens in bleeding is that when we prepare concrete freshly, bleeding occurs when the water comes onto the surface of the concrete. Okay. So bleeding is basically a segregation process in which the water comes onto the surface of concrete when it is freshly mixed or freshly prepared. The water must not come onto the surface. Bleeding is a great threat to the integrity of the construction or the integrity of the building. So fineness minimizes the process of bleeding. Next effect will be shrinkage and cracks. Because of fineness, the shrinkage and cracks in cement increases. Okay, these are all the effects of fineness. Now we will watch a video to understand the fineness. The fineness test of cement. Look at this picture. Here you can see the 90 micron sieve. This is the sieve lead. This is the sieve staking machine, the wine balance and cement. Let's watch the video.
Determination of fineness of cement by sieve analysis. The fineness of cement has a positive impact on the rate of hydration, which in turn impact the rate of gain of strength and the rate of evolution of heat. The increase in fineness of cement increases the drying shrinkage of concrete. Furthermore, having higher finer cement particles leads to a faster setting, reducing the time for mixing, handling and placing. The fineness of cement is measured in two ways, by sieving and determining a specific surface by air permeability apparatus. In this video, we look at the fineness of cement using sieve analysis. So let's find the fineness value for the selected sample of cement. To do so, take 100 gram of cement sample, weighing balance which can weigh with an accuracy of 1 milligram, standard sieve of size 90 micron, sieve pan with lathe and sieve shaking machine. Take a cement sample of 100 gram, which is free from lumps and note it as W1. Transfer the cement sample into 90 micron sieve and fit the lid over the sieve. Now place the sieve in the sieve shaking machine for 2 minutes. You can also perform this by shaking the sieve with your hands by agitating the sieve in planetary and linear movements for 15 minutes. Now, weigh the residue retained on the 90 micron sieve and take it as W2. Finally, calculate the percentage of the weight of cement retained on sieve by the formula W2 by W1 into 100. Repeat the experiment with 3 different cement samples and average the values for accurate results. As per IS recommendation, the percentage of weight retained on the sieve must be less than 10%. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views and find.
So now you have watched the video how the experiment is conducted. Are there any doubts? किसी को पूछना है? Are there any queries? Please be feel free to ask any doubts you are having. Let's watch another. पूछना है? डाउट है कुछ? नो?